So the next topic is the third module, that is your embedded system. Okay. So what is meant by an embedded system? It is an electronic or an electromechanical system designed to perform a specific function, and it will be a combination of both your hardware and software. Okay. So in the case of embedded system, the software is called as firmware because it is a code which is used to run the particular hardware. Okay. So normally it is most of the cases it is called as your firmware. Okay. The example of the embedded systems are numerous examples: household appliances such as your washing machine, microwave oven, or your air condition, etc., telecommunications, medical equipments, industrial control, consumer products, etc. So the next topic is the difference between your general purpose computing system and your embedded system. So in the case of general purpose computing system, it is a combination of both a generic hardware as well as a general purpose operating system. Whereas in the case of embedded system, you have a special purpose hardware and embedded operating system. The second is it contains a general purpose operating system. In the case of embedded system, it may or may not have a OS for the functioning. Then the third one is applications are alterable by the user in the case of general purpose computing system, whereas in the case of your embedded system, the firmware of the embedded system is pre-programmed so that it is not alterable. For example, in the case of washing machine, you cannot change the codes, right? It is already pre-programmed. The next one is a performance is the key deciding factor in the selection of the system in the general purpose computing system, whereas in the case of embedded system, it is not only the performance, it takes the power requirements, memory usage are the key factor deciding factors. Then in the case of GPCS, that is your general purpose computing system, it is not less or not tailored towards reduced operating power requirements, meaning it uses high power, whereas in the case of embedded system, it uses low power, that is highly tailored to take advantage of the power saving mode supported by the hardware and the operating system. For example, in the Arduino, you can use it, the power required is only 3.3 volt, right? These are some of the example. Yeah, next one is the response requirements are not time critical, but whereas in the case of embedded system, most of the cases it is time critical. For example, for mission critical system, the response time requirement is highly critical. For example, if you use an inertial navigation system, it is very highly time critical. It is and in the case of the last one is it may not be deterministic in execution behavior, whereas it is deterministic for certain type of embedded system. It is, for example, the hard real time systems. The next topic is your classification. Mostly the classification is based on four different category. The embedded system can be classified based on generation, the complexity and performance requirements, deterministic behavior, and triggering. So as per your syllabus, you are going to study the first two types based on the generation and complexity and performance requirements. So generation first, second, third, fourth goes on. So in the first generation, it uses 8-bit microprocessor and 4-bit microcontroller. Okay. Example is digital telephone, keypads, stepper motor, control units, etc. The second generation, it uses 16-bit microprocessor and 8 or 16-bit microcontroller. Instruction set is very complex and powerful. Example, SCADA, supervisory controller and data acquisition system. Okay, the third generation, it is now modified again to 32-bit microprocessor and 16-bit microcontroller with processors such as DSP, ASIC processors, Intel, Pentium, Motorola, 68K, etc. Examples are robotics, media, industrial processing control, networking, etc. The fourth generation includes now it is converted into a system on chip, that is SoC, configurable processors. Example is your smartphone, MIDs, etc. So second classification is based on your complexity and performance requirements. So based on the complexity and performance requirements, it is again divided into small scale embedded system, medium scale embedded system, and large scale or complex system. So in the case of small scale embedded system, it is very simple in applications. Performance requirements is not critical. Example are your electronic toy, and it is built by 8 or 16-bit microprocessor or microcontroller, or may not have an operating system. Whereas in the case of medium scale complexity performance requirements, medium scale embedded system, it is slightly complex and it uses 16 or 32 bit microprocessor or microcontroller, or a DSP or and the operating system is present. Okay, so in the case of large scale or complex system, you have it is the system is highly complex, so it uses 32 or 64 bit RISC microprocessor or microcontroller, and or your RSOC, and it uses real time operating system. Okay, these are the different classifications.